Everyone, and welcome to Activity 8. Today we are going to talk about the composition of functions. Now, what are a composition of functions? Well, those are when we have functions that are made when one is placed inside of the other. So, for example, if we look at the function 2x minus 1 quantity squared, we can say that that function is composed of two other functions, right? What are they? Well, the first one we could say that the inside piece here is 2 minus x, and then that function is kind of coming inside of this z squared function. So imagine if we have z squared and we kind of broke it up so that we were placing something else inside of it. It's like we are placing that 2x minus 1 inside of that function, and then that's how we're getting that resulting function of 2x squared, right, as our function. So the notation that we see with this looks like so. So in this case, we would say f of g of x. So basically what we're saying is we are plugging the function in g of x inside of our function f of x. So g is what we would call the inside function or the inner function of function f. And we, again, are placing that inside. And it's very important to note that the order is important in these because it's not going to be necessarily simplifying to be the same thing. It's in many cases it's not going to be the same. So when we have f of g of x and g of f of x, they are very different functions. Again, whatever one is listed closer to the x, that is going to be your inner function, and then the outer function then would be the one on the outside. So something to be very careful of as well, because it could affect how we not only compose, but then finally simplify. So each time when we actually simplify these, we want to make sure we get that ordering correct. If it is in the fancier notation, make sure we rewrite it so we remember which function is getting plugged in, that inner function, and then we always want to simplify once we do that. Okay, so this time we are being asked in our first example to find g of h of x. So essentially we are plugging the h of x function into function g. So g of x is our outer function, right? This guy is our outer function. So we have 2, and then we're going to be plugging in a function for x squared, and then minus 7 times that function for x as well. So anywhere we see the x in this original, we are now going to plug in h of x. So where we have 2x squared, it's now going to be 3x minus 5 squared, and then we had negative 7 times x, and again, x is this piece here. Now, a reminder, when you have a function whose quantity is squared, that is the same thing as saying 3x minus 5 times 3x minus 5 as we go to expand this out. So we got to be careful because we have 2 times 3x minus 5 times 3x minus 5, and then we have that negative 7 times 3x minus 5 just one time. So this first part, we are going to need to expand FOIL this out. So we have the 2 on the outside. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. And then we're also going to do the same thing with that. Negative 5 gets distributed through. Negative 5 times 3x, negative 15x. Negative 5 times negative 5 is positive 25. And then on the second part, we also have this negative 7 we can distribute. We have negative 21x plus 35, negative times negative. And then we need to also distribute this, actually let's combine first. So we have this 2 on the outside, but we have 9x squared minus 30x on the inside plus 25. And then over here we had minus 21x plus 35. That's still here, the minus 21x plus 35. And then we're getting there. We need to also distribute this 2 to those pieces. So we have 18x squared minus 60x plus 50, and then still minus 21x plus 35. And then last but not least, we're going to combine like terms. We have 18x squared, and then we have minus 60x minus 21 more x's for negative 81 x's. And then finally, plus 50, but plus 35 more, so plus 85. So this would be our final composed answer. Now, had we gone the other way, all right, you cannot assume that h of g of x would have been the same thing. All right, this time they asked us for g of h of x, though. In our next example, all right, this time we are being asked for g of f of x. So f of x, again, is going to be that inner function this time. G of x is on the outside. So we have g of x, which is 5x squared minus 3. And anywhere we see an x in this original, we are plugging in square root of 2x minus 5. Now, when we start simplifying here, we are squaring a square root, so those are actually going to cancel out, and we are just left with 2x minus 5. And if we distribute that 5 through, we get 10x minus 25. Still have that minus 3 hanging out. And then last but not least, combine these like terms, 10x minus 28 ends up being our composition. Last example on this page is looking for f of h of x this time. So this time our outer function is f of x. So we have 2 times x plus 9. And anywhere we see an x in that outer function, we are going to plug in our h of x, right? So where we had this x is now 5 over x plus 3. Well, when we start simplifying this, what we notice is the only thing we can simplify is that we are multiplying 2 times this piece here. Well, the 2 is going to be multiplied by the 5 when we distribute, and we won't have to worry about distributing to the x plus 3 because this goes with the numerator. So our final answer ends up just being 2 times 5, which is 10, over x plus 3 plus 9. And that's as simplified as that one is going to get. On the last page, there are 2 for you to try yourself. This first one, you are finding f of g of x, and make sure you simplify. Second one, you are finding k of j of x. Make sure you simplify. Thanks everyone for watching, and we will work more with compositions in class.